So this is what chapter 6?
This is section 6.1, roots and radical expressions. A radical is this symbol right here. But we can also deal with something like the fourth root. And I could ask for the fourth root of 16. And what this means is I am asking what number raised to the fourth power gives me 16. That number could be 2 or it could be negative 2. I have my function f of x is the square root of x and g of x is the cubed root of x. And what I'm going to be concerned with here is I want to find the domain for each function. So for the square root, what we're looking at is an example like the square root of negative 16. Can anybody tell me what the square root of negative 16 is? We're just going to say that this is non-real for today. We are going to deal more with things like this tomorrow. It could be 4i or negative 4i, but for now just say non-real. Point being, the domain of the square root is actually 0 to infinity because we cannot plug in negative numbers. Domain is the set of all possible inputs, so all possible inputs to the square root, 0 to infinity, including 0 because the square root of 0 is 0. The domain of the cubed root is negative infinity to infinity. Reason being, I can take the cubed root of negative 8. Cubed root of negative 8 is negative 2. Because negative 2 cubed is negative 8. So I can plug negative numbers into the cubed root, just not into the square root. That's how we get those domains. And that is actually going to be true. This works for all even roots. That's the domain of the function if it's an even root, square root, fourth root, sixth root, eighth root, etc. This is the domain for all odd roots. So 3, 5, 7, 9, so on and so on like that. So we want all the real square roots. Start with negative 0.81. If the square root of 81 is 9, then the square root of negative 0.81 is non-real. It's negative. I was purposefully trying to mislead, though. Mr. Rule, what would the square root of 0.81 be? 0.9. We could also say negative 0.9. People. Now, square root of 25, Mr. Weick, stop that, over 49. If you are taking the square root of a quotient just meaning division, the radical can split up. It can be the root of 25 over the root of 49, which we can all recognize to be 5/7, or it could be negative 5/7. Want the real square roots of 121. Those are going to be 11 or negative 11. Now again, the book talks about what is called the principal root. Mr. Weick, again, stop it. What the book does with principal root is if they write square root of 121, they are looking for 11. If they write negative square root of 121, they are looking for negative 11. I would prefer you to just understand that if I ask what number squared gives you 121, for example, you understand that it could be 11 or it could be negative 11. It could be both. So the first one, the square root of 0.36, we're going to go with 0.6 or negative 0.6. And in each class, somebody has been a little concerned with, well, wouldn't it be 0.06? If you remember the rules for multiplying decimals, or if you just get your calculator out, you can really quickly see that it should be 0.6, not 0.06. The cubed root of negative 1. What is the negative 1? Again, that's because negative 1 cubed is negative 1. And this is asking, what number cubed gives me negative 1? So the answer is negative 1. So we said the cubed root of negative 1 is negative 1. So then what is the square root of negative 17 squared? Mr. Graber?
17.
We could say 17 or negative 17. When you have this situation, the square root of something squared, you can just get rid of the radical and the exponent. You get negative 17. This is another rule the book talks about. Mr. Parris, would you stop? This is another rule the book talks about that we're not going to stress in here. If you have something like the square root of a to the fourth, they're going to say that that is, well, that wouldn't matter. If it's the square root of a to the sixth, they're going to say that's something like the absolute value of a cubed. Again, if you're looking in the book for reference, don't worry about this sort of rule. What is the simplified form of the square root of 25a to the fourth? Just like earlier, when the radical went over the quotient, the radical will also go over the product. So the square root of 25a to the fourth is the square root of 25 times the square root of a to the fourth. The square root of 25 is 5. The square root of a to the fourth is a squared, so it's 5a squared, or it could be negative 5a squared. Now, there are a couple ways to think about this. You could think about that as the square root of a squared squared. And like we had with that negative 17 example, if you have the square root of something squared, then this goes away and this goes away, we're left with a squared. That's one way of thinking about it. Another way of thinking about it is saying it's the square root of a to the fourth, meaning this is a 2, because if there's nothing written there, it's an implied 2. And you can think about this as a to the 4 divided by 2, and 4 divided by 2 is 2. Perfect. This one again, it splits up. We have the fourth root of p to the 12th times the fourth root of q to the 4th, which is p to the 3rd q, using this rule, or negative p cubed q. So we have our equation. S is the square root of 15d. Does the 180 meters get plugged in for S or for D? Therefore, we have that S is the square root of 15 times 180. Using your calculator, what is that rounded to the nearest thousandth?
2,700. 50. Hold on.
It should be 51 point
96152.
That's what I was saying.
962, measured in what units? They tell us in the first sentence of the problem, yes, meters per second. We have our formula, V equals 4 square root P. V is the voltage of an audio system speaker. P is the power of the speaker. An engineer wants to design a speaker with 400 watts of power. What will the voltage be? Does 400 get plugged in for V or for P? P. So we have V is 4 times the square root of 400. So we have that V is 4 times 20, which is 80. And those are 80 what? Volts, right? The conversation.
Well, that's mean.
They say it's measured in watts?
Volts.
What?
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 Watts?
Excellent.
Watts.
Excellent. Watts.
Watts?
Outstanding.
Volts?
9.
9?
9.
It's voltage, volts.
Volts.
Volts. On these last two problems, we did not worry about the negative root. Why not?
Because you can't have negative volts, right?
And in the last problem,
Even.
we only deal with the positive root because of the context
The question.
of the problem. Having negative volts doesn't make sense. In the last problem, having negative speed doesn't make sense. If you end up taking physics, you'll learn that velocity can be negative, but speed cannot be. So in a word problem, you have to understand if you need to just use the principal root or if you need to use the negative one as well.